Year 12. Today what we're looking at is derivative of exponential functions. So our learning goals are to establish and use the formula, the derivative of a to the power of x is equal to ln a of a to the power of x. We're also going to review how to differentiate exponential functions that we learnt last year. So differentiation rules for exponential functions are that if we have y equals e to the x, then the derivative of e to the x is e to the x. We also have this on our reference sheet as if y equals e to the f of x, then the derivative is equal to the derivative of the power, so f dash x, e to the power of fx. So this is on your reference sheet and you can find this on page 3. I'll show you where it is right now. So on your reference sheet on page 3, that is this formula right here. So the derivative of an exponential function. So you never have to remember it. It is always there for you. Of exponential function. So yeah, it is always there for you. You just need to make sure that you know what it means and how to use it. So let's have a little review of the derivative of exponential functions. Our first example says that if f of x equals 4e to the power of x, find the equation of the tangent to the curve at 2 and then 4e squared. So remember when we're finding the equation to the tangent of the curve, we have to find the gradient and then we have to use our point to substitute into y minus y1 equals m lots of x minus x1. So our first step here is to differentiate. So if we were to differentiate this, we just have a coefficient of 4 that stays the same, and the derivative of e to the x is just e to the x. What we then do is we let x equal our x value in here, which is 2. So we substitute in 2 into our derivative. So f dash of 2 is 4e to the power of 2. And so what this means is we therefore have that our gradient of our tangent is equal to 4e squared at our point 2, 4e squared. What we're then going to do is we are going to substitute this into our gradient intercept form. So our y minus y1 of m bracket x minus x1, our point gradient formula, not our gradient intercept. So when we substitute into this, we get y minus our y1 is 4e squared equals our gradient of 4e squared lots of x minus 2. From here, we just expand our bracket to have y minus 4e squared is equal to 4e squared x minus 8e squared. From here, we can either make y the subject or we can put it in general form. So if we were to make y the subject, we would plus 4e squared to both sides. This leaves us with y equals 4e squared x minus 4e squared. And if we were to put it into general form, we would minus the y across, because general form is when we have ax plus by plus c equals 0, where our a is greater than 0. So we would have that 4e squared x minus y minus 4e squared equals 0. So either one of these are correct in finding the equation of the tangent of the curve. It just depends which form we're asked for. If you're not asked for a form, you can choose. Our next question is to differentiate y equals x cubed e to the x. Now we have two x's visible here. So when we have two x's visible, that means we want to use our product rule. So our product rule is also on our reference sheet, and it is y dash equals uv dash plus vu dash. So we want to first identify our u and our v, our u dash and our v dash. So our u is equal to x cubed, and the derivative of u is equal to 3x squared. We then have our v, is equal to e to the x. So our v dash is also equal to e to the x. We then just want to substitute these into our formula. So we'll have that y dash is equal to our u, which is x cubed, times by our y dash, which is e to the x, plus our v, which is e to the x, times by our u dash, which is 3x squared. I don't know why it keeps bugging out like that, sorry. So what we then have is y dash is equal to, and we want to see what is common in each term. So in each term, we can factorize out, an e to the power of x, and we also can factorize out an x squared. So if we factorize out an x squared, e to the x, we are, in our first term, we are just left with an x, and in our second term, we're just left with our 3. For our next one, we have y equals e to the power of 9x. So we're going to use that rule from our reference sheet, which is y equals e to the f of x is what we've been given. And the derivative of this is y dash equals f dash x of e to the fx. So what we can do is we can work out we can say what our fx is. Our fx is equal to 9x. So our f dash x is equal to 9. This is what we're then going to substitute in. So when we get our y dash, it is equal to our f dash x of 9, e to the power of our fx, which is 9x. So the derivative of e to the power of 9x is just 9e to the power of 9x. Same scenario with our next one, y equals e to the power of 6x minus 5. So we have it in the form of y equals e to the power of fx to y dash equals f dash x e to the power of fx. So we'll have that our fx in this case is equal to 6x minus 5, and the derivative of that is equal to 6. So that means our y dash will equal our derivative of 6 e to the power of fx, which is 6x minus 5. Finally, we can differentiate other exponential functions. This is something that we didn't look at last year, which was if we have y equals a to the power of fx, then the derivative is equal to ln a f dash x of a to the power of fx. And this formula is also on our reference sheet. It is on page 3 as well, underneath that exponentials formula. So looking at our annotated reference sheet, it is this one here. I won't write derivative of exponentials with different bases on it right now. I'll save that and do that in a second. But it is on page 3 there. So going back to our example, if we want to differentiate y equals 7 to the power of x, we want to use that formula. So we have it in the form y equals a to the power of x, and our derivative is going to be ln a of f dash x of a to the power of fx. So in this case, what we have is we have our a is equal to 7. We have our fx is just equal to x, and our f dash x is equal to 1. So what this means is our y dash will equal ln a, so ln 7, lots of 1, so times 1, times our a, which is 7 to the power of x. Sorry, I should have given you an extra line, but what this then just equals is ln 7 times 7 to the power of x.